Greetings, viewers, and welcome to Nebula Engineering. Today, we're diving into a fascinating journey, the creation of smart railway wheels. It all begins with solid steel billets, the raw material that forms the backbone of these ultra-durable wheels. Each billet is precisely cut to perfection. Then, in a swift and seamless motion, a smart robotic arm picks up the billets and carefully places them into a massive furnace. Inside, the blazing furnace heats the billets to an optimal temperature, softening the steel and preparing it for the upcoming transformation. These once solid steel blocks are now ready to be reshaped in one of the most revolutionary manufacturing steps yet. Stay tuned to Nebula Engineering as we uncover the next phase in the journey of creating railway wheels, the driving force behind modern transportation technology. Don't look away. What's coming next will leave you in awe. Imagine the scene. A massive robotic arm, glowing red from the heat, hoists steel billets weighing several tons high into the air. With unparalleled precision, it carefully places each billet into a colossal forging press, a machine of unimaginable power, applying immense force to compress the steel and shape it into perfect circles, the precursors of ultra-durable railway wheels. This process isn't just about shaping, it's a spectacle of technological might. Under the pressure of thousands of tons, the steel billets are forged into products with exceptional strength, ready to bear the enormous loads and stresses of railway operations. But the story doesn't end here. As the semi-finished wheels leave the forging press, a gigantic rolling mill awaits. With enormous rotating cylinders and meticulously controlled pressure, the wheels are further refined. This precision rolling process not only perfects the shape, but also creates a smooth, flawless surface, an essential factor for ensuring safety and performance under all operating conditions. Once the shaping is complete, the wheels move to the most critical phase, heat treatment in high-capacity furnaces. Here they undergo rigorous cycles of heating and controlled cooling. This process optimizes the wheel's hardness and wear resistance, preparing them to withstand the most extreme challenges. This isn't just manufacturing, it's a monumental feat of engineering, where massive machines and human ingenuity come together to create technological marvels. After the heat treatment process is complete, the glowing wheels, radiating strength and precision, are transferred to the colossal CNC machining systems. Like a symphony of mechanical choreography, these machines cut, grind, and refine each wheel with precision measured down to the micrometer. Absolute accuracy is paramount, as even the slightest deviation can compromise the performance and lifespan of the wheel. The machining begins on a state-of-the-art vertical CNC lathe, where the oxidized surface layer is stripped away, revealing the pure, solid steel core, an immaculate product forged to perfection. Intelligent robotic arms work tirelessly, moving wheels seamlessly from one stage to the next, demonstrating incredible speed and fluidity. This high level of automation minimizes errors, ensuring every wheel meets the strictest quality standards. But the journey doesn't stop there. The wheels proceed to advanced ultrasonic testing, where a fully submerged ultrasonic flaw detector employs cutting-edge technology to scan deep within each wheel, ensuring no hidden defects escape detection. Only wheels that pass this rigorous inspection move on to the final stage, finishing. During finishing, the surface hardness is tested using an automatic digital hardness tester, while the wheels undergo precise balancing on a vertical static balancing machine. Every detail, every motion is executed with unmatched precision, guaranteeing that the wheels achieve flawless smoothness and stability in their performance. Next in this meticulous journey, we arrive at a critical inspection step: magnetic particle testing. Here, the automated fluorescent magnetic particle flaw detector takes on the vital task of uncovering even the tiniest surface cracks, ensuring each wheel not only meets but exceeds the strictest safety standards. The finer details come to life through specialized machining operations, such as oil hole drilling, plate hole machining, and bore grinding, all performed with absolute precision. Once every step is complete, the wheels are automatically marked, creating a system of flawless traceability. Moving forward, we enter the realm of axle forging, a breathtaking display of technological power and absolute precision. It all begins with cutting raw axle steel using an automatic bandsaw, where every cut is meticulously calculated to ensure the billet weight is perfect for the next forging phase. The steel billets are then transported to a massive furnace, where temperatures are finely tuned to the exact degree. Here, the steel becomes malleable, ready for its transformation in a high-powered forging process that shapes it into axles of perfect dimensions and form. Once forged, the axles are aligned using a hydraulic straightening machine, ensuring they meet strict dimensional standards. With precision alignment achieved, the axles advance to a fully automated continuous heat treatment line. Utilizing a high-capacity electric heating system, each steel axle is evenly heated and processed to achieve uniformity in structure and maximum durability, critical for the demands of modern railway operations. Every detail, every motion stands as a testament to the unwavering pursuit of perfection in modern engineering. Continuing this journey of precision engineering, we arrive at one of the most critical stages in axle manufacturing: heat treatment and rough machining. This is where cutting-edge technology is pushed to its limits, ensuring that every detail meets accuracy down to the millimeter, laying the foundation for unmatched safety and performance in railway operations. First, the high-powered double saw machine begins its work with incredible precision, processing both ends of the axle to refine its surface flawlessly. Following this, the automatic centering machine carefully machines the central holes of the axle, ensuring that every axle meets exacting standards. Next comes the axial ultrasonic inspection process, where the smallest internal defects are detected and eliminated. This indispensable step guarantees that the internal structure of the axle is flawless and ready to withstand the rigorous demands of railway operations. Moving forward, we explore the wheel set press machine, a state-of-the-art system specifically designed to assemble and disassemble critical components like wheels, brake discs, and gears. Utilizing enormous hydraulic force, it presses these parts onto the axle with absolute precision, creating a secure and durable fit. The system's versatility allows it to handle any type of railway vehicle, from passenger trains and wagons to urban metro cars, regardless of whether they use standard or broad gauge. Beyond assembly, the advanced press machine also excels at disassembling components when necessary, offering seamless support for both maintenance and assembly tasks. Notably, it conducts pressure tests on wheel sets to ensure they meet the strictest safety and performance standards. All of this is controlled by a sophisticated computer-driven system, fully automating the processes and delivering unmatched precision and efficiency. This is not just technology, it is the pinnacle of perfection in the railway manufacturing industry. Let's dive into a groundbreaking advancement in the railway industry: advanced computer-controlled technology and precision measurement, transforming the wheel-set press machine into an indispensable tool for the production and maintenance of modern railway vehicles. This is not just a machine, but a cornerstone of performance and accuracy, supporting overhaul and reconditioning processes for final drive assemblies and bogies. The overhaul process begins with meticulous disassembly and thorough inspection of critical components using non-destructive testing (NDT) techniques. Cutting-edge methods like ultrasonic testing, UAT, and magnetic particle inspection (MPI) are employed to detect even the smallest flaws, ensuring every component is restored to peak condition before reassembly. Computer-controlled profiling systems ensure absolute precision in restoring wheel sets to their original specifications. Meanwhile, state-of-the-art dynamic restoration and balancing processes guarantee unparalleled stability and adherence to the strictest operational standards. Bearings undergo detailed inspections and are replaced when necessary, further reinforcing the commitment to perfection in every aspect. This isn't just maintenance, it's an industrial masterpiece where cutting-edge technology meets expert craftsmanship to restore critical components to their optimal operational state. Bogies, the heart of any railway system, undergo a comprehensive inspection and refurbishment process. The frame, suspension components, and braking systems are meticulously examined to ensure nothing is overlooked. Following this, the braking system is reassembled and subjected to rigorous testing, ensuring compliance with the highest safety and performance standards. These processes not only extend the lifespan of critical components, but also minimize downtime, optimizing operational efficiency in the locomotive and railway industry. But the story doesn't stop there. Let's step into the realm of high-tech bearing manufacturing, where absolute precision and advanced materials make all the difference. It all begins with selecting raw materials, high-grade carbon steel or titanium alloys, some of the toughest materials in the world, engineered to withstand extreme mechanical loads. The process continues with forging and rolling, transforming raw materials into inner rings, outer rings, and rollers, the essential components of a bearing. One of the most critical stages in bearing production is heat treatment. Bearing parts undergo advanced thermal processing methods, including carburizing and tempering, to enhance hardness and wear resistance. This step is crucial to ensure that bearings can operate reliably and durably under the most demanding conditions. Every step, every stage is a testament to the marvels of modern technology, where world-class materials and meticulous processes create superior products. A highly skilled workforce. From planning and process control to continuous improvement, every stage is guided by top-tier professionals. The synergy between human expertise and advanced technology is the cornerstone of ensuring flawless quality in every bearing produced. Not only do these skilled personnel execute tasks with precision, but they also play a pivotal role in early detection and timely correction of deviations, maintaining a stable and efficient production flow. A culture of innovation and continuous improvement is deeply embedded in every aspect of the process, ensuring that each product not only meets but surpasses the industry's stringent standards. This is not just manufacturing, it's an industrial art, where skilled hands and sharp minds merge with cutting-edge technology to create products of global excellence. In the modern industrial world, bearings are not just ordinary mechanical components. They are the foundation of performance and reliability in countless complex systems. With a global market value estimated at $110 billion in 2023, bearings are emerging as one of the fastest-growing sectors, projected to reach $172 billion by 2030, with a compound annual growth rate of 6.5%. This rapid expansion is driven by increasing demand across critical industries such as automotive, wind energy, aerospace, and manufacturing, where high performance and maximum reliability are non-negotiable.